Hello, you're welcome to Classic Data Lab, where we provide you with the needed skills to extract insight, add value, and make impact from data. In today's video, I'm going to teach you data structures in Python. Data structures forms part of the foundation of every programming language. In fact, computer programming is basically data structures and algorithms. So it is important that after you've covered data types in Python programming, you also get a firm understanding of data structures in Python because they go hand in hand. Make sure you try your best and watch to the end of the video so you can get the best out of this lesson. Having mentioned the importance of data structures, let's get started. What are data structures then? Data structures basically refers to a format of for storing, organizing, processing, and accessing data. Right? You can view data structures as containers or special containers for holding or storing data. In our natural world, we have different containers for storing different substances, right? Okay, so for instance, you have oil, water, and salt. You may want to store the oil maybe in a bottle, right? And then store the salt in a container that allows you to open and take some, and the water you may also want to store it in a bottle, right? It doesn't mean that you can't store maybe salt in a bottle. If you want to do, you can also do that, right? What I'm trying to let us know is that when it comes to programming, the different data type you've learned can be stored in different data structures, right? And the core data structures in Python includes lists, tuples, dictionaries, and sets. I take them again: list, tuples, dictionaries, and sets. There are other data structures that we will find later in other packages and libraries, but for the core data types in Python, these are what they are: the list, the tuples, dictionaries, and sets. We are going to take them one by one, but in this lesson we are going to cover lists and tuples. Great. Before we move on with lists and tuples, I want you to pay attention to some basic terms that helps us differentiate or know the different characteristics of the different data structures. Okay, number one is mutable. When we say a data structure is mutable, it means it allows you to do changes. Once you create it, you can add, you can remove data from it, you can add data to it. And when we say a data structure or data type is immutable, it means that once you create it, you can't change it, you can't make changes to it. It is stuck. It's like a sealed package. You can't add, you can't deduct from it. And then when we say data structure is ordered, what it means is that each data type in the data structure has an index position. So definitely you can call the data in the data structure using an index, right? Like 0, 1, 2, 3, 4, 5. So the positions are being numbered or being kept, right? That is ordering for you. Okay, so now that we've learned the basics, we know what data structures are, we know the different basic types of data structures in Python, and we know the terms that help us to differentiate them. Let's move on to list. All right. So in Python programming, you can create a list using the square bracket or the list function, right? But before even we move on to learn how to create lists, it's important for us to know that lists are mutable, one of the flexible data types in Python, right? They are mutable, that is, you can add or remove from a list. They can hold different data types and data structures at the same time. So if you want to create a list can contain a different data type or data structures in it. Don't worry, you'll see examples very soon, right? And then lists are ordered. That means that if you have your data structure stored in a list, you can basically call the first data type, the first item, the second item. You can call them out and you know their index positions. Okay, so that's list for you. So let's demonstrate with examples here. I have a list called weekdays, right? And you could see that I've used the square bracket here. Then whatever is in there, or you can see there, are the days of the week, okay, and they are all strings. So the data type here are strings, and then the data structure is what? A list, right? So that is the structure is the container, and then the data type is referred as the substance. Okay, good. And I have another list here, and here in this case I have Ghana as a string, football as a string. I have 2, which is an integer, true, which is a boolean, and 5.9, which is a float, telling you that a list in Python can hold different data types at the same time, right? And then the last example you can see here is called my second list. And in my second list, we have strings, as you can see, Roger, Derek, right, as strings. We have 100, which is an integer, and we have another list that is Ghana football 2. That basically my list in there being contained in my second list, right? So that's it. And then a boolean, right? So the list is able to contain a list in itself, right? That's why I said lists are one of the most flexible data types in Python. It allows you to put different types of data structures or data types together in it. Okay, so after I've created it, I'm going to run this code, and then I will call them one by one, and you could see them being printed out, right? Good. That's a list for you, right? Very soon you will see the importance of a list and how they are being used, but for now, just get the foundations right. Okay, let's see what we can do. We made mention of the fact that lists are mutable. That means you can change or add data to it, right? Good. We will see that right away. But before then, if you have any data structure which is not a list, and you want to convert it to a list, you can use the list function, right? So for instance, we have numbers here which are tuples. I know you've not treated tuples at the moment, but no worries. I want to change this tuple to a list. I will use the list function, and that's it. Now when I check the type, you realize that it's not a list. Okay, so you can create a list using the square bracket or using the list function, right? Normally we use the list function when we want to convert a particular data structure to a list. All right, good. So then let's move to the indexing, because we said lists are ordered and they are flexible, they are mutable. That means we can add to a list and we can deduct from a list, or we can remove an element from a list. We are going to demonstrate that right away, right? So I have a list here called items, and we have pen, pencil, eraser, book, table, chairs, computer, right? Assuming I want to get access to the first item, I can index it like we learned previously. If you are not familiar with indexing, I will admonish you to watch my previous tutorials on strings, and I taught on indexing a lot. It's the similar principle that is applied to list. All right, so I want to get the first one. Remember, Python is zero-based indexing, so it starts counting from 0, right? So the first element is having the index 0. So when I say items square bracket 0, it's going to return pen, as you can see over here. The same way, if I want the second one, I will use 1 items 1, and that is it. If you want to do negative indexing or reverse indexing, that means you want to start from the right to the left. You just negate the numbers, right? No, having in mind that we don't have negative 0, right? So negative 1 will return the last element. Negative 3 will return to you the third element, counting from your right, right? Good. So that's it. That's list indexing. This is possible because list allows us to do so. That means it orders the items and give them index position, so you can easily index from a list. Not all data types allows you to do indexing in this way. All right, then we have list slicing. As we learned with strings, you can also take a chunk or a portion of a list, right? And we have our colon here, which basically means that if you don't specify anything before the colon or after the colon, it means you are referring to all elements in that particular data structure or in that list, and that's why we are getting all the items in the item list, right? When I say item square bracket 3 and then I bring the colon sign, what I mean is that from the third value going. So 0, 1, 2, 3 upward. Okay, so when I run this, you could see it start from book. That means 0, 1, 2, 3 to the end. So book, table, chairs, computer. Okay, I'm taking from the third value onwards. The same way I can also do negative indexing and say neg 1, neg 2, neg 3, neg 4, right? From negative 4 to the right, not to the left, from negative 4 to the right, and I'll get the same results. Okay, so you can use negative indexing or use the positive indexing. Remember, if you are using indexing from the left to the right, the counting starts from 0, but if you are starting from the right to the left, it starts as in negative 1. Okay, downwards, negative 1, negative 2, negative 3, negative 4. So the reverse indexing, basically you have to use negative values, right? So, and remember where the negative 4 came, it came before the colon. That means that from negative 4 upwards, from 3 upward, if I bring the value after the colon, that means that I want that one to be my limit. So from 0 to that particular value. So when I say item square bracket colon and then negative 4, as you can see here, basically what I'm trying to say is that start from 0, right? So 0, 1, 2. So this is the negative 4 is this particular one, right? The book, because negative 1, negative 2, negative 3, negative 4 is here. So if I say from 0 to negative 4, that means it's going to start here 0, 1, 2. Then it wouldn't add the book because Python doesn't include upper boundaries, right? It always excludes the upper boundary. That's why you're not seeing the book in there, right? So be very careful. So if you want to add the book rather, then you should rather make it negative 3, right? And the same principle applies to the positive indexing. That if you are indexing from right to the left, okay, the same principle applies. So be very careful about that, right? Like I have here, this is a positive indexing from left to right. I want to get these items here, right? 0, 1, 2, 3, 4. This is the fourth one, but Python will exclude this. This is the upper boundary where it ends. So it always exclude the end value, right? The ending index. So you will get pen, pencil, eraser, book, right? So let's run this and see what I'm going to get. Exactly, that's it. All right. There's one thing that you also have to pay attention to. That is, if you want to do index maybe on based on some let me say some specific interval, right? So for instance, I want to get every second value, right, in the list. Let's start with the first element first. So the first element, so it's pen, so 0, 1, 2. So that's it. So it return after pen, eraser, then it continues like that, right? So what is it? 1, 2, it returns it. 1, 2, it returns. So every second one it return it, and that's what you are getting here, right? This type of indexing is very, very important because we want to return maybe some kind of index interval in a particular data set, okay? And knowing these tricks will help you do that, right? I will talk more about this kind of indexing when we get to data manipulation with pandas. And let me remind you, in case you want to get access to this particular lab, kindly visit the link I provided in the video description, right? That is the link to Classic Data Lab GitHub repository. All the labs that are used for the tutorials can be found over there. Feel free to download it, use it, change the codes, and learn, right? Practice makes you perfect, so don't hesitate to get access to these labs and use them for your learning. All right, so let's continue with more examples here. We have what we call my second list, which was which is a complex list because it contains a list in it, right? So you can call it a compound data type if you wish. If I want to index this, right, I want to get Derek, I can easily get it by using 0 indexing, right? So let me say my second list index 0. When I run this, you realize that Derek has been returned. Okay, what about if I want to get access to Ghana? Realize that Ghana is in what? Ghana is in another list inside the list. Okay, so if you think 0, 1, 2, 3, so I'm going to use 3 to return Ghana. The moment you key in 3, you realize that the whole list is rather returned, right? So how do you get Ghana in this case? All right, and that is where you have to do chaining. Okay, so after you've indexed this, you've gotten the list inside there, you can still use a square bracket and return 0, and then it will return Ghana to you, right? So you can continue using the square brackets in that order, right? It doesn't just apply to a list, but any data structure that you are able to get another structure in it, you can still move on with your square brackets or whatever you use to index to continue getting elements in that data structure. Okay, so that is something you should pay attention to. And you can also update a data structure, a list. Okay, for instance, we have football, which is capital capital FOOTBALL. Okay, football. But I want to change it to small letters. It shouldn't be capital. I want to make it. I want it to start with a lower case. Easily, I can do that. I have to make sure that I access that particular value, right? That particular let me say data type, and then make changes to it or equate it to whatever I want. So for instance, if I want to get the football, I'll first use list 3, index 3, as you can see here, right? Then I will bring a square bracket in there, and I'll pick football should be 1. That's it, right? So now that I have gotten it, it's the same thing that you can see here. I'm just going to equate it to what I want to change it to, and that's football with the capital small f. Okay, after I'm done, and I'll call my second list now. It's no more capital F, it's now small f. That means that a list allows me to do changes to it, right? The same way you can also do to Derek. Assuming the Derek spelling, you want to change Derek to, let's change Derek to whatever name you want and say Desmond, right? Derek, from Derek to Desmond. Now, when, oh, this will give me an error. Sorry for that. I'll just copy this, cut this rather, and then I will rather index 0. Okay, then I will equate it. Please don't use double equal to. You are assigning it, so you have to use single equal to Derek Desmond here, right? When I run this now, and then I call my second list, you will realize that it has been changed from Derek to Desmond. You are able to do this because lists are mutable. It allows you to change it, add it, and change whatever you want in the list. Okay, we will see more examples below when we learn about methods in a list. All right, so some basic built-in functions that can be used on a list. Now, every data structure allows certain functions to work on them. Okay, we will talk about functions and methods later, but for now, just understand the basic concepts I'm trying to portray here, right? So for list, some of the basic functions is like the len, the min, the max, the sum, the sorted, right? Just to mention a few. These functions or commands allows you to work on a list. All right, so you can, for instance, have weekdays. You want to know how many data types or how many elements are there in the weekdays list. When you say len weekdays, you will get 8 over here, and you realize that there are 5 elements in there, right? My second list will also return 5, because if you are going to count my second list, as we saw over here, it's going to be 0, 1, or you can start 1, 2, 3. Then this whole thing, right? This whole list is seen as one item, so that will be 4 and then 5, and that's why when we check for the length, it retains 5. Okay, right? So that's the length function. Very, very basic. The min and the max functions are used to return the least value and the maximum value respectively, right, of any numeric data. When you use them on strings, you will get an answer, but you definitely will not make sense to you because it's just comparing the strings using ASCII values, and that's not what you want. So if you search for the minimum, the mean of the weekdays, you are likely to get perhaps maybe Friday as the minimum, right? Because it starts with F, which it comes first before other ones. Okay, or comparing Monday and Friday, you know, F comes first before M, so definitely you will see F as the minimum. This is something that you should pay attention to. So I advise you don't use the min and the max on strings. It's basically for floats and integers. That means if the list contains floats and integers, it will be very okay to use the main function on it. So for example, we have profit here, right, as a let me say as a variable, and want to get the minimum profit that we made from our sales, right? It's 100. What's the maximum profit that we made? Is what? 9,890. Okay, as I mentioned earlier on, let's see weekdays. When we ask for the mean of weekdays here, you see that it's returning Friday. When we ask for the max, it's returning Wednesday, right? And you confused. How come Friday is the minimum day and then Wednesday is the maximum day? And do we even have minimum day and maximum day, right? I'm bringing this because if you use the function, it will definitely return something to you, and you'll be wondering how it got it. It's just using ASCII values, right? Something that is we are not going to tackle in this particular tutorial, maybe later, but I don't think it's so important to cover it as at now, right? So it basically compares the position of the alphabets. That's it. Okay, so we also have weekends here, so that's a similar example here, right? Now the sum function allows you to sum elements in a list. Okay, so list, you can apply the sum function on a list. When we talk of the sorted, it basically means you want arranging your elements or your data in ascending order or descending order. List allows you to do that. You can easily order it, right, using the sorted functions. The sorted function. All right, so here I'm just trying to make a statement and then print out the outcome. Okay, so do not focus on the statement, the printing per se, just focus on the sorted function here. So this is the data points and I want to sort it. I'll just put in sorted then points, and you realize that it has sorted it from the least to the greatest. If I want to do the reverse, I just have to indicate that reverse equals true. That means I'm arranging it in descending order, and that is what you are seeing over here, right? So that these are basic functions that you can apply on a list. We will learn more as we progress. Now, another thing you need to know is what we call list methods, or methods that are list related, right? We have, remember we saw sorted, but this is sort. And we have append, extend, pop, remove, insert, and so on. There are a lot of them. I'm just going to show you the basic one. So the sort basically works like that of the sorted function, right? However, there's a clear difference between a function and then a method. When we get to object-oriented programming, you realize that though they have the same, they may have the same functionality and stuff, but the way they are created or where they find themselves are quite different. Okay, so do not get yourself confused. You just learn the basics for now. When we get to object-oriented programming, I will create a function, I'll create an object, and you will see I will create a function and a method, and I'll show you the difference, and you get to understand it better. Make sure you subscribe to this YouTube channel, and don't forget to hit the notification bell so that anytime I upload a video, you will get access to it, or you'll be notified about it. All right, so the sorted here, this is sort method rather. So profit dot sort. Okay, you realize that the method rather bring a dot before it, right? You will later understand this. So it will do the same thing for me. Now when I say profit, when I call, you realize that it didn't really make you didn't really see the changes per se. I don't know whether you can even see it. Oh no, the changes has been made already. Yeah, it has made it in the sense that it has arranged it from descend, because we say reverse, it has arranged it from descending to what? To in the descending order. Yeah. Now, if I don't bring the reverse equal to true, it's going to arrange it in the ascending order. One thing you should notice that the moment you use the sorted method, it affects the main data, right? The main one we created, right? However, if you use the sorted method, the sorted function, it doesn't change the main data. This is something that you should pay attention to. Now we have another method called the append. The append method is used to add elements to a list, right? Add elements to a list. That is, if you want to just do cut and paste, you take all these elements, you add it to the list over there. So let's have a list called letter, that is ABCD. That's a list. Assuming I want to add another letter like Z to it, I can use the append method. So I'll say letters.append, then I'll supply whatever I want to append to the previous list, and it will add it for me. So now when I append list, you could see that the Z is being added. That's the append for you. Basically, it just do cut and paste. Right, so let's have names here. We have names like Albert, Ben, Carol, and Donna. Now I want to add a name like Eugenia to it, right? I can just append Eugenia, and that's it. And I can also use the sorted function to sort it, and it is sorting it based on the first alphabet. Okay, that's in alphabetical order, right? So that's the append method for you. The question then is, do you have to memorize all these functions and methods, right? I would say no. However, if as you continuously use them, they become part of you. But to make a conscious effort to memorize them wouldn't help. Okay, so there are ways of just saying them or getting to know from any text editor that you are using. So if you are using Jupyter Notebook, there's a way that you can let Jupyter Notebook suggest the methods that are related to a particular data structure for us. And in case you are also not familiar with a particular function, you can also use the help function to know more about it. For instance, the len, assume I don't know anything about len, right? The len method or the len function, I can just write the len and then bring a question mark to it, and when I run this, it will tell me what it does. It will print a documentation telling me what the len function does. Okay, so it returns the number of items in a container, right? That is in a data structure. And you can also use the help, right? If you don't want to use the question mark, you can use the help, and you get the same information, right? So anytime you get stuck, you don't know what to do with a particular function or how to use it, make sure you use the help function, all right, to get that. I'll also teach you more about that, the methods, how to also know method that relate to a particular data structure. Now, beside the append, there is another method called extend, which is very important to know, right? Very important. So for instance, I have list 1 here and I have list 2 here. List 1 contains footballers like Messi, Ronaldo, Mbappe, and Modric, and list 2 contains Mane, Salah, Neymar, and Depay. If I want to add the players in list 2 to the players in list 1, I may be tempted to use the append. Let's see what happens if you use the append method. The moment you run this, you realize that it cut the list 2 and then it pasted it in the list 1, right? But that's not what I'm expecting. I want the individual player names there to be added to the names in list 1, right? So that is where the extend is needed. So the extend method extend list by appending elements from any iterable, right, or from the data structure that you are picking the data from. Okay, so for instance, you have the list 1 here, as I'm doing it again over here, and then I want to add the names in list 2 to the list 1. I will use the extend, and when I use the extend, you see the difference here. You realize that now the individual players that are being added, okay, didn't just cut them and paste paste the list in the first list. It picked the data there and then added it to the first list. And pay attention once again that the moment you run the method on a list, or so far what we've done, you realize that the list is affected. The main one, the original one, is affected. Now, if you call list 1, you're not going to get Messi, Ronaldo, Mbappe, or Modric. You're going to get them in addition to Mane, Salah, Neymar, and Depay, as you can see over here. This is because lists are mutable. So whatever action you do to it changes the list itself, okay? Unless maybe you use a function, but if you use a method, usually it will change and the effect will be left in there. We will later dive deep into these things. Okay, so another method that I want to tackle is the pop method. It removes and return the last element of a list by default. Okay, the last element of a list by default. That is, if you want to, if I have a list like words here, boy, girl, man, dog, and man, and I want to remove the last element and return it, I'm just see it. Okay, I can use the pop method. So the pop, when used in the list, okay, remove the last element and then returns it by default, unless maybe I specify that maybe remove the first one or a different thing. Okay, so that's the pop for you. So the more you run pop on a particular list, the more it keep on reducing because it's just taking away the last element. Now let's talk about the remove method. Basically, it works like the pop, just that with the remove method, you have to specify what you want to remove. It's not basically the last one, but specify that, oh, for instance, I have colors here, red, gold, green, indigo, and I want to remove the gold. I will just say colors.remove gold, and that is it. In as much as you can remove from a list, the same way you can also insert to a list. All that you need to do is use the insert method, specify the position, right, that you want your element to appear for. For instance, I want to insert yellow to the colors, but I want to appear in the second position or as with the second index. So I have 0, 1, 2, right? So I'll just specify that I want 2, and then the item to insert is yellow. When I run this, colors become red, green, yellow, indigo. That is 0, 1, 2, right? That is it's here. So that is the insert method. You can also update a list as we learned earlier on. Just make sure that you get the index of that particular element you want to change and equate it to the new item. So for instance, you have list 1 here. I can just index, I want to change, let's say, Mbappe to Haaland. So I will just index Mbappe and then I equate it to what? Haaland. That's 0, 1, 2, and I equate to Haaland. Now when I call this, I will not see Mbappe anymore. I will rather see Haaland. That is the updating aspect. You can also add, okay, instead of maybe making a change, you can add, and that's basically what we've learned so far using the append method. Assuming you have, let's say you have list 1 over here, okay, and you want to know which methods can be applied to it, right? I've taught that in the previous tutorial, but I'm mentioning it again. Just write the data structure, bring a dot and press the tab right on your keyboard. Just press tab. You realize that it will show you all the methods that you can, that comes with that particular data structure. Okay, it's not limited to data structures alone. Even data types, you will see it over there, right? If you're using other IDs like maybe PyCharm or VS Code, you will see the suggestions just popping up like that. So you don't need to press the tab. But for Jupyter Notebook, you need to press tab to be able to see the methods available for you. All right, so that's list for you. I thought I could add tuples right away, but it's getting too long. I'm going to treat tuples in another video. All right, so just a quick review. We've learned that there are the 4 basic data types in data structures in Python includes lists, tuples, dictionaries, and sets. Okay, and then the four basic data types in Python includes that of the integers, the float, the booleans, and then strings. Okay, so data types are different from data structures. Data types can be referred as the substance, right? And then the data structures can be referred as containers for holding or for keeping or storing those substances. Okay, good. And then we focused on lists, and we learned that lists can be created using the square brackets, right? They are mutable, and you can also update the list because they are mutable. You can, it's ordered because of that you can index elements from a list and so on, right? Now in our next video we are going to treat tuples. Please don't forget to hit the subscribe button, and thank you for watching this video. See you in the next video where we will address tuples. Bye for now. Happy learning.